let's talk about composite forces, because these are the ones that we're going to talk mostly about in this class and that you're going to use kind of every day in these units. So composite forces. It's inconvenient, and let me be a little more precise and say it's actually impossible to use fundamental forces for kind of describing what's actually going on. Instead, we summarize by combining them into these composite forces. So if you want to know why that is, for example, if I'm holding this pen, right, there's millions upon billions upon even more atoms in my fingers, and each of those atoms has a bunch of electrons in them, and then there's millions upon billions of atoms in this pen, and each of those have a bunch of electrons in them. So what's actually helping me to hold this pen up is all of the electrons in my thumb basically are repelling the electrons in the pen, and there's so many of them that it ends up being enough to equal the force that it's being pulled on by gravity. But if we were to try to calculate that, we just don't have the computational power, because it's, you know, all of these electrons on this side and all of these electrons on this side. And if we wanted to do the calculation properly, it's the force between that first electron and all of those, the second electron and all of those, the third electron and all of those. And just imagine this for billions of electrons on each side. Like, it's just not possible to do that calculation and add them all up to find the total force. So instead, we look at these composite forces, which are kind of approximations that we use that kind of describe a certain situation and the force that we see as a result of all of these electromagnetic forces combined. So let's look at some examples. Whoops, sorry. First, we have the normal force. And this is a push force that is perpendicular to two surfaces. So this is, if you're pushing on something, you're exerting a normal force. If I'm pushing on my face here, my hand has a normal force going that way against my face, and my face has a normal force going that way against my hand. Normal is a math word for perpendicular, so that's why we call this a normal force. And normal forces are always push forces. Next, we have what was this next one? Oh, sorry, yeah, that's friction. I don't know why I had such a hard time figuring that out. So then we have friction. And this acts, this is also sort of a push force that acts parallel to two surfaces. And opposes their relative motion. And we'll talk about all of these forces in greater detail later. So again, my hand on my face, if I slide my hand down, my hand is trying to move down on my face, so it will experience a frictional force going up. My face is effectively trying to move up on my hand, so it will experience a friction force down. And that's because there's two forces that are moving relative to each other. Next, we have tension force. And this is a pull force that acts parallel, or that acts along a rope or other object. So for example, if you're pulling on a rope, then that rope can pull on another object with a tension force. So there's tension throughout that rope. The rope is all being pulled in the direction of the two objects. Next we have spring force, and that is a push or a pull force that opposes the stretching or compressing of a spring. So if I have a spring and I try to squeeze it, it's going to push against that squeezing. Likewise, if I try to stretch it, it's going to act against it. It's going to pull back on it. So a spring is a push or pull force that opposes the stretching or compressing of a spring. You can think about it as the force that tries to make the spring go back to its normal or neutral position. So those are our basic forces. The rest of the details about each one of these will get discussed in a separate video.